Hi, let us learn the transforms of Heaviside unit function and unit impulse function. The unit step function, which is otherwise called as Heaviside's unit function, denoted by u of t minus a, is defined as u of t minus a equal to 0 when t is less than a and 1 when t is greater than or equal to a. In particular, if a is equal to 0, u of t equal to 0 when t less than 0 and 1 when t greater than or equal to 0. Now, L of u of t minus a, that is Laplace transform of a unit step function, is equal to e power minus as by s. If a is equal to 0, L of u of t is equal to 1 by s. If f of s is equal to L of f of t, so this is the first shift property, then f of s minus a, we know that it is equal to L of e power st f of t. Note that if f of t minus a, u of t minus a, the product function is defined as 0 if t less than a, f of t minus a if t greater than or equal to a. Now the second shift property states that L of f of t minus a, u of t minus a equal to e power minus as f of s, and L inverse of e power minus as f of s is equal to f of t minus a, u of t minus a. So all these formula are to be remembered while solving the problem, especially the second shift property and the definition of unit step function. Now going on with unit impulse function, so we'll only learn the definition here. That is delta epsilon of t minus a is equal to 1 by epsilon t varying from a to a plus epsilon and 0 in all other cases. Laplace transform of delta of t minus a is equal to e power minus as. Now let us see how to solve the problems in unit step function. Problems express the following functions in terms of unit step function and find their Laplace transforms. So the first question is f of t minus a is equal to 2t for t varying from 0 to pi and 1 for t greater than pi. So by definition of unit step function, we know that u of t minus pi, in this case a is equal to pi. So u of t minus pi is equal to 0 when t less than pi, and it is equal to 1 when t greater than pi, relating this to the definition of unit step function. Now let us express f of t. Now we have to write this function using u of t minus pi. So we can write f of t in terms of unit step function as f of t equal to 2t minus 2t into u of t minus pi. Now what happens here when we write only this is that when when t is less than pi, u of t minus pi is 0. So it will become 0 here and we will get the respective function when t less than pi. But when t greater than pi, u of t minus pi is 1. So if u of t minus pi is 1, 2t minus 2t is 0. But we are supposed to get the value 1. Therefore, we are going to introduce another, that is add the term u of t minus pi. So we have to write this f of t in such a way that when we apply the conditions t less than pi, we will get 2t and t greater than pi, we should get 1. Therefore, we are going to add the term u of t minus pi to this function. So now what happens? F of t will be equal to 2t minus 2t into u of t minus pi plus u of t minus pi, wherein we can write this, taking u of t minus pi common, we can write it as 2t plus minus 2t plus 1 into u of t minus pi. Now what happens here when t less than pi? U of t minus pi is 0. So this term is 0 and this term is 0, we will get 2t. So t less than pi, we will get 2t. Next, when t is greater than pi, u of t minus pi is equal to 1. So this is u of t minus pi will be equal to 1, and this is 1. 1 into minus 2t is minus 2t, plus 2t will become 0. So 0 plus 1, we will get 1. So the function as defined should be written using step function. Now let us apply, at this stage we have to apply the second shift property. To apply the second shift property, u of t minus pi must be a function of t minus pi. Therefore, now we have minus 2t plus 1 here, that should be expressed as a function of t minus pi. Therefore, we will write minus 2t plus 1 equal to minus 2 into t minus pi minus of 2 pi minus 1. When we simplify, we will get back minus 2t plus 1. So f of t, now this function f of t will be written as 2t minus 2 into this 2t minus 2t plus 1 is expressed this way. So minus 2t minus pi into u of t minus pi into u of t minus pi minus 2 pi minus 1, okay, into u of t minus pi. So having got f of t as a function of t minus pi and u of t minus pi, we need to take Laplace transform on both sides. So we already know by second shift property that L of f of t minus a into u of t minus a is equal to e power minus as f of s. Therefore, using that, take L on both sides of this function. We will get then L of f of t equal to L of 2t minus 2 is a constant, moved outside the transform, minus 2 L of t minus pi u of t minus pi. So this is where we are going to use the shift property, second shift property, minus 2 pi minus 1 L of, so we have only u of t minus pi, we are going to write it as 1 into u of t minus pi. So we know that L of t is 1 by s square, so 2 into 1 by s square minus 2. So for this we are going to use the second shift property, and we will get e power minus as f of s. F of s is transform of this function t. So in this case, function of t minus a. In this case, f of t is t. So transform f of s of t is nothing but 1 by s square e power minus pi s. So f of s is 1 by s square into e power minus pi s. T minus pi means it is nothing but function of t minus a. So function of t will be t. Okay, now the next term, minus 2 pi minus 1 L of 1. L of 1 we know that it is. So L of 1 into this. In this case f of t is 1. So f of s will be 1 by s into e power minus pi s. So again this term is also written using second shift property. Hence the solution. Now the next problem, if we see, we have power 2. So f of t is equal to t square, t varying from 0 to 2 and 6 for t varying t greater than 2. So we can write f of t as t square minus t square u of t minus 2 plus 6 u of t minus 2. So we are rewriting this function defined in this form such that when t is less than 2, when t less than 2, what happens? We will get f of t as t square. These two terms become 0 because when t less than 2, u of t minus pi is t minus 2 is 0. When t greater than 2, u of t minus 2 is 1 by the definition of step function. So minus t square plus 6, okay, that is what we are going to write because here we have minus t square plus 6. That should be written as a function of t minus 2. So what I am going to do here is minus t square, okay, plus 4t minus 4t, and 6 is written as minus 4 plus 1. Group the terms. This is nothing but t minus 2 whole square minus 4 into t minus 2 plus 2. At this stage, we will get f of t as a function of t minus 2 and u of t minus 2. At this stage, we have to take Laplace transform on both sides. So L of f of t is equal to L of t square minus L of t minus 2 whole square u of t minus 2. But we know that L of t square is 2 by s cube. 2 factorial by s power 2 plus 1. Therefore, L of t minus 2 whole square u of t minus 2 is 2 by s cube e power minus 2s, and minus 4 L of t minus 2. So, L of t means transform of t is 1 by s. Transform of t is 1 by s square. So, we will get 1 by s square e power minus 2s plus 2 into transform of 1 is 1 by s e power minus 2s, and hence the solution. Thank you.